Hey, good morning, friends. How are you? Let's start our today's session. That is based on the exercise based on IUPAC nomenclature. We have complete outline with some basic five principles. In this session, we are going to learn how you will give the name of common alkane, right? So here I'm going to draw one alkane. That is a bond line formula of one alkane. At every corner, there is a one carbon. At every corner, there is a one carbon. Is it clear, my dear friends? See, it's very easy. It's very easy. Now, see, this is a carbon. All I am going to show you in a red symbols. So that all are the carbons. That's clear. So here it's a six carbon exactly. So what is this exactly? That is a alkane because there is no availability of the double bond. There is no availability of the double bond, so it's alkane. So now how we will use the prefix? How we will use the prefix? So let's discuss the prefix first of all, right? If there is a one carbon, then that is a meth. It's there is two carbon, then it's eth. If there is a three carbon, then there is a prop. Three carbon, it's a prop. Four carbon, that is a but. Four carbon, it's a but. They all are known as a prefix, my dear friends. So you have to first of all identify the longest carbon chain, then after identify the number of carbons, and based on that number of carbon you can use the prefix as I'm going to show you. For 7, that is a hept. For 8, it's a oct. For 9, it's non. For 10, it's dec. See, that's given in our NCRT syllabus. But beyond it, suppose you are preparing for JEE Main or JEE Advanced, then you can go with the 11. That means UN is 10 for the 1 and DEC is 10. So on DEC for 11. See here, UN symbolized as a 1. And 10 means DEC. 12 means do DEC. 12 means do DEC. Do is 10 for the 2. Clear? 13, 1, 3, 13 is a tridec, 14 tetradec, and so on. You can write the till the 20, but that's not our in syllabus. So we are not going to discuss here in details. Right now we have to only focus on 1 to the 10 prefix only, right? That is a meth, eth, prop, but, pant, hag, sap, talk, non, and dec. Clear? See, it's very easy. Don't confuse your brain. Now, first rule, remember, that is a select the longest carbon chain, and then after selecting the longest carbon chain, what you have to do? You have to identify the substituent. But here there is no substituent. Clear? There is no any substituent here. If you want to write for the 16, then you can write the hexadec 2. Now, how we will give the name of this alkane? Is there any double bond? No, there is no any double bond. All are single, so it's a alkane, and there is a 6 carbon, which means hex will be used as a prefix. Hex will be used as a prefix due to availability of the 6 carbon in the longest carbon chain. So here I will use 6 as a 6 as a symbol of carbons, and due to the unavailability of the double bond, it's alkane. And in alkane all are single bonds, so suffix a and e is used. Hex is prefix. Hex is prefix for the 6 carbon, and a and e from the alkane. So this is become the formula for hexane. Is it clear how to write the hexane? So by this way you can write hexane. Now in this case you can calculate the number of carbon: 1, 2, 3, 4, 5, 6, and 7. So number of carbon is 7, so prefix will be hept. I'm sure you are getting my all points. So the prefix will be a hept, and no availability of double bond, and all are single bond, so it's a ane alkane. Due to the alkane, it's a ane as a used as a suffix. So the name of the compound become heptane. Name of the compound become heptane. See, don't forget to like the video, subscribe the video, and comment the video. Now in this case, how we will name this compound? 1, 2, 3, 4, 5. Clear? All corners shows the carbon. Don't forget that. 5 carbon, pent. All are single bond, ane, pentane. Clear? By this way you can prepare till decant. See here, I'm just showing you the bond line formula, so don't forget it. Now in this case, my dear friends, be careful. Here we are going to start the next, that is a cyclo compound, ring compound. In this you can check, this is a closed cycle. One cycle is there. Calculate the number of carbon. It's a 5 carbon ring. It's a 5 carbon closed ring. Clear? In this case, how we will use the word? Remember, you have to note down one thing. See, this is a cyclic compound. This is a cyclic compound where the all carbons are forming one closed ring, and at every point there is a hydrogen, as you learn in a previous lectures. Clear? But here not going to show that hydrogen. Now in this case, how we will give the name? So you will use cyclo as a prefix. Cyclo as a prefix. Don't forget it. Clear? Cyclo as a prefix, and number of carbon is 5. So we will use pent, and all are single bond. Cyclo as a prefix, pent due to 5 carbon, and ane shows the all are single bond. No double bond is there. Cyclo is for the ring. Don't forget it. Pent is for the 5 carbon. Pent is for the 5 carbon, and ane for the single bond. Ane for the single bond or alkane. Clear? So this is an example of cycloalkane. It's an example of cycloalkane. Is it difficult? It's very easy. It's very easy. Please try to understand. Now let's solve the next question. Let's solve the next question. I'm sure you understand all this. So please take a screenshot, my dear friends. Don't forget to take a screenshot. Now let's start the next question. See, now one more example of the cyclic compound. Suppose the name is given cyclonone. Now how we will draw the structure? Cyclo shows the closed ring. Cyclo shows the closed ring. Clear? Non shows the 9 carbon. And ane shows, very good, ane shows single bond or alkane. So how we will show? You have to draw 9 carbon ring. Here due to the inaccuracy, maybe you are not getting that particular points, but please try to understand. I'm trying my best to explain that in a figure. At every point I'm going to draw that particular 1, 2, 3, 4, 5, 6, 7, 8. Not possible, not possible. So let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. Alright. So that will be a 9. Done. So now check it, the carbon points. I'm going to show that particular carbon, so don't worry about it. This is the first carbon, second carbon, third, fourth, fifth, sixth, 7, 8, and that should be 9. Clear? So you have to, what you have to do, understand? You have to draw 9 carbon in a ring. Make ring of 9 carbon. Clear? And this is an example of cyclonone because it's a ring, 9 carbon, all single bond. Now how you will draw the octane? Oct means 8 carbon. ane means all single bond. Oct means 8 carbon and ane means single bond. So you have to put 8 carbons all having single bonds. Clear? See, every time it's not necessary to show that in a bond line angle structure. But remember that, don't forget to watch that previous video, how to write the condensed formula, structural formula and bond angle formula. If you will not understand that, then this video will be not useful for you. Clear? This is a structure of octane. This is a structure of octane. I'm sure you all understand this. Alright. So thank you. So friends, let's start the next session with the more examples. In this case, we are going to solve branch chain alkane, and previous session we have just completed the formula for the simple alkanes. Here I'm going to show you one branch chain alkane. See, that is one branch, that is not a continuous chain, that is not one simple alkane, but you can check one thing, that on a first, second and third. So on a third carbon, there is the availability of one branch. So that branch is exactly what? Clear? So before we start to learn that, first of all, you have to identify the longest carbon chain. So here the longest carbon chain, you can check that here I'm going to show you. That will be your longest carbon chain. Is it clear? It contains one, two, three, one. Yes, you can check 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 carbon chain, which is the longest carbon chain. And on a third carbon, you can check that there is one line shows. Clear? It's a longest carbon chain. You understand? It's the longest carbon chain, and which contain the 9 carbon atoms. 9 means it's very clear, non, and no double bond is there. So you will use ane as a suffix. So non-n will be the root name. Non-n will be the root name. Now you can check one thing, my dear friends. On a third carbon, there is a one line. What is line shows? On that top of the line, there should be carbon. But as you know, in the line angle formula, we are not showing that according to our theories, right? So on that pink point here, I'm going to show the carbon. There should be hydrogen, but according to line angle definition, we are not showing the hydrogen in any cases. So this is a first carbon, one carbon. So we will use the prefix meth. Are you getting my point, my dear friends? So the prefix will be used as a meth for the one carbon. You can't say it's a methane because it's not attached with the fourth hydrogen. So meth means one carbon and it is attached with one parent chain. It's attached with one parent chain. So you will use suffix YL. So the name became methyl. Name became methyl. So methyl, or sometimes we say methyl. YL shows the branches of longest carbon chain. YL shows the branches of longest carbon chain. Now how we will give the name, so here the name will be, you can think that it's a methyl nonane. But what difficulties are faced when you are writing this name? So let's check that difficulties. First of all, you will state that the name will become, there is availability of methyl and nonane, so name will become methyl nonane, which is not true. Why it's not true? Here I'm going to show nonane in a similar color as it is written in a later, and methyl with that similar color, pink. Okay, let me check that. Let me change that color. So here I'm changing to the pink. Yes. So now there is a one problem, methyl nonane. So where is the position of methyl? That is not identified in a name. Clear? The first figure is also true, second is also true. So what you have to do, you have to give the number that methyl group is attached with which carbon. So for that you have to check lecture number 9, where we have discussed that how to give numbering. You have to give numbering in a way that your substituent must get the lowest possible number, right? So from the beginning you will start the numbering. So your methyl will get the number third. Clear? That is the lowest possible number. If you will start from the another side, then it will get the largest number, which is against the rule. So I always say, my dear friends, please prepare all the rules in detail. If you will not prepare the rules, then subject will be more difficult for you. So on a third carbon, you can check there is a methyl group, right? So the name will become 3-methyl nonane. Name will become 3-methyl nonane. Yes, here I'm going to show that 3 in a yellow. So 3-methyl nonane. And what we learn? We learn that number and letter is separated by hyphen, while two numbers are separated by the comma. Clear? And first letter should be capital, and everything is written in a single lines. So by this way you can give the numbering, while in this second example 1, 2, 3, 4, it's a 4-methyl nonane. Both are the different examples. Both are the different compounds. Clear? Where the position of methyl group is different, you can check one thing. On a first there is a methyl group at the third position, while in a second example there is a, on a fourth carbon there is availability of the methyl group. So they both are the different. having the same formula, and that kind of compounds are known as isomer that we are going to discuss later on. Clear? So right now don't focus on it. It's a 4-methyl non-N. Both are the different one. So the numbering is very, very important. Clear? And always give the number in a way that your compound should be at the lowest possible number. Now here I'm going to solve one more example, but please watch it very carefully. Here I'm going to make one mistake, and what you have to do, you have to identify my mistake and you have to give that particular mistakes reformation into the your given WhatsApp number. Clear? Don't forget that. Here I'm going to make one mistake for you. It's a 2-propyl heptane. 2-propyl heptane. Now check how I'm going to make a mistake. 2-propyl heptane. Here I'm going to make mistake for you. Please check it. And what you have to do, I already tell that is the error. I'm going to make error. A shows the all single bonds are there. A shows all single bonds are there. Hep shows the 7 carbon, and propyl, that means on a second carbon there will be a 1 propyl group. Hept matlab 7 carbon, and on a second carbon there is a propyl group. So now see, check how I'm going to draw that structure. This is a wrong structure. I already tell it's it made as error because I want to check that how many students are active students. So please correct this and send me your solution for that. Okay, alright, so that is a, you can check 1, 2, 3, 4, 5, 6, 7 carbon heptane. On a second one, I'm going to show you the propyl group. On 7,1 propyl, second carbon. On a second carbon, there will be a propyl group. So let me show you that particular propyl group here. Okay, 1, 2, 3. Done. So you can check carbon 1, 2, 3. So it is known as a propyl group which is attached on a second carbon, but the given name is wrong name because there is yes, you got it. It's against the first rule. It's against the first rule. So please try to find out the answer. Now let's solve the second one. 6-butyl tetradecane. 6-butyl tetradecane. So let's solve that 6-butyl tetradecane. First of all, tetradecane, it shows the 14 carbons, 1,4 carbon. This is an example for the JEE main. Be careful, my dear friends. It's an example for the JEE main. Tetradecane, 14 carbons, 1,4 carbons, and all having a single bonds only. All having a single bonds. So let's draw that structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. On 6 carbon there is a butyl. 1, 2, 3, 4, 5, 6. On the 6 carbon, see, first of all I'm going to give you the numbers 12, 13 and 14. On a 6 carbon, let's check it. On a 6 carbon there is a butyl group. Butyl group having a 4 carbons. Yes, okay. On this 6 carbon you have to show butyl group. So how you will show the butyl group? Please check it. Please check it, my dear friends. Butyl 4 carbon. Butyl 4 carbon. How we will show this butyl group? So butane, you know, CH3, CH2, CH2, CH3. But from the butane, if one hydrogen is less, then it's known as a butyl. So on a 6 carbon, let me show you that particular butyl group. 1, 2, 3, 4. Now I have to attach this. You can check 1, 2, 3, 4. It's attached with the 6 carbon. So this is an example of 6-butyl tetradecane. It's an example of the 6-butyl tetradecane. You understand, my dear friends? See, this kind of example can be asked in your examinations. So always try to solve the question based on the concept only and apply your own logics. See, if you will add this butyl at the other position, then the numbering, if you will use from the left hand side or the right hand side, then in both the case you will get the different compound. In this case, you can't tell it's a 1 2 3. From the right hand side you have to give the numbering, and 1 2 3 4 5 6, that will become 6 butyl tetradecane. Clear? So it matters only that how you are going to give number. You have to give a number in a way that your substituent must get the lowest possible number. Clear? So thank you, my dear friends. We will meet in the next lecture. Till then, please don't forget to subscribe the video.